All right, so we're looking at the Unit 4 Day 2 warm-up. So we're just going to kind of review the stuff that we did yesterday in class. Yesterday we were talking about our normal distribution frequencies. And a lot like we did in Unit 3, our central limit theorem told us that the more samples that we take, the closer that our sample mean becomes our population mean, and the more normal that our information becomes. Even if our distribution didn't start out normal, the more sample means that we take, the more normal our data gets. So if we look at these examples, it says the average time it takes to get through security at the Denver airport is 42 minutes with a standard deviation of 11 minutes. Determine the probability a single randomly chosen passenger will wait between 30 and 45 minutes in line at security. So this is going back to our Unit 3. So we have our normal curve. Our wait time is 42 minutes. Our mean wait time is 42 minutes. And we want to know about waiting between 30 and 45. So we want to know this region here. So we're going to do our normal CDF. We're looking between 30 and 45. Our bounds are 30 and 45 with a mean of 42 and a standard deviation of 11. Right, we do our lower bounds of our shaded region, then the upper bounds of our shaded region, and then this is always our mean, and this is always our standard deviation. So to compute that on my calculator, I hit second vars. I pick number 2, which is my normal CDF. My lower bound is 30. My upper bound is 45. My mean is 42. And my standard deviation 11. So when I compute that, I get that the probability is 0.4698. So our next question says, consider a sample of 50 travelers and find the probability their mean wait time will be between 30 and 45 minutes. So this is where we're taking sample means. This is where our central limit theorem comes in. Remember, for our central limit theorem, nothing changes about our mean. The only thing that changes is our standard deviation. So our curve would look the same. We're still looking for our normal CDF. Our lower bound is still 30. Our upper bound is still 45. Our mean stays the same. The only thing that changes is our standard deviation is going to be divided by the square root of how many people, or our n value. So here n is 50. We talked to 50 travelers. So we're going to compute that and see the difference in our answer. So what I typically do on my calculator is I'll just highlight this and then change that 11 to divided by the square root of 50. Close my parentheses. Remember the only thing that changed. So now my probability, if I talk to 50 people, is 9731. Right, the more samples that I take, the more normally distributed my data becomes, the more my information moves towards the middle. So since I'm looking for numbers in the middle, there's a higher probability that my numbers are going to fall here, the more people that I ask. So you could go ahead and try to pause the video and try the next one, but I'm going to go over it. In a survey of a company, the mean salary of an employee is $29,321 with a standard deviation of 2,120. Determine the probability a single randomly chosen person will have a salary less than $29,000. So we'll draw our curve. And then my mean is 29,321. And I want to know if someone will make less than 29,000. So I'm a little less than my mean. And I'm looking for this shaded region over here, everything less than that. So when I set up my curve, or when I set up my normal CDF, my lower bound, right, I'm going all the way to the end of this picture. So this is my negative end, so I'll do negative 1e to the 99. My upper bound was 29,000. My mean, 29,321. And my standard deviation, 2,120. So again, we get our calculator. Second vars, we do our normal CDF. I'm going to go from negative 1 e to the 99, 29,000, 29,321 is my mean, 2,120 is my standard deviation. So I'm filling all that information out into my calculator, and then I'll let it find the probability for me. So 0.4398 is my probability. So then my next question asks, consider a sample of 100 employees. So now we're not just asking a single person, we're talking to 100 employees. So N is 100. Find the probability their mean salary will be less than 29,000. So we're still finding the same shaded region, but now for an N value of 100. So the only thing that's going to change is our standard deviation. So I'm still going -1 e to the 99. I'm still going from 29,000. My mean is still the same, but my standard deviation becomes 2,120 divided by the square root of 100. So when I do that, again, I'm just going to highlight this one because basically all my information is the same. I just need to change this last thing to divided by the square root of 100. So then I end up with a probability of 0.0650 when I round that. Which makes sense because we've talked about, right? The more people that we ask, the more normal our data is becoming, the more likely it is to be close to the mean. The probability of a lot of people of your N value increasing and your mean varying from the population mean is highly unlikely. So it makes sense that that value is going down because we're looking for information outside of our mean. All right, so then it asks, what is the pay for the bottom 10% of employees? So this is something from our unit 3. Remember, I want to know the bottom 10% of my curve. So I want to know this part here. But I don't know any of the values except for I know my mean and my standard deviation. My mean is still the same and my standard deviation is the same. But I don't know what this value is that represents the bottom 10%. But we can find it. Remember, we use the button NV norm. So if I hit second vars and I go to number 3, sorry, I didn't do that in the screen. I go second vars down to number 3. So the area that I want 0.1% of my area, 10%. My mean is 29321. My standard deviation is 2,000. And then if this is possible on your calculator, you would select the left tail. If this is not, your calculator is always assuming the left tail. So in this case, you don't need to do anything. We looked at unit 3. Sometimes if your calculator doesn't let you pick right or left, you have to do something else. But they all default to the left end of your graph. So the bottom 10% makes and then our mean was, and then this was left. The bottom 10% makes $26,604.11. All right, so that is a review of our warm-up before we go ahead and get started with our notes for today.